Hey guys, in 7-6 we're learning about similar figures. Similar figures are a little bit different from congruent figures. Just to remember, refresh your memories, we need to remember that congruent figures have the same size and shape. Congruent figures have the same size and shape, so basically they're the same, right? However, for similar figures have the same shape but not necessarily the same size. So congruent means like, let's say these were about the same size, that would be congruent, they're the same. Similar means the same triangle but a much bigger size. Okay, so this is similar. This is congruent. Okay, congruent means the same size and shape. Similar means the same shape but not the same size. It could be, but maybe not. So, for polygons to be similar, you should write this down. First of all, corresponding angles must be congruent, meaning that this angle must be the same as this angle. These must be the same as these. And this one needs to be the same with this one. And then corresponding sides must have lengths that form equivalent ratios. Equivalent ratios means that 2 to 4 to 4 to 6 is an equivalent ratio. Okay? So, example 1, we're using scale factor to find a missing dimension. Scale factors to find missing dimensions. So we have a picture that's 4 inches tall and 9 inches wide. So let's go ahead and draw that picture for ourselves. It's 4 inches tall and 9 inches wide. And I know it's not drawn to scale. But for it to be scaled, picture 4 inch tall and 9 inch wide is to be scaled to 2.5 inches tall to be displayed on a web display. So they want to draw it where it's 2.5 inches tall. And then now we have to figure out how wide should the picture be on the web page for them to be similar. Okay, so they're the same picture, but in real life it's 4 inches tall, but they want it to be only 2.5 inches tall. So we have to figure out what is the width of this picture. So the first thing we need to find out is the scale factor. What the scale factor is going to tell us is basically what we need to multiply the second number by. Okay, so in order to find the scale factor, what we're going to do is we're going to put the small number above the larger number, so 2.5 inches to 4 inches, and that's going to get us about 0.625. This is our scale factor. Okay, that's what we want to scale it to. So in order to figure out the width right here, what we're going to do is we're going to do 9 times 0.625, and then we're going to get 5.625 inches. Okay, so the second picture's width needs to be 5.625 inches. And the way we got it is we figured out the scale factor and then we multiplied the width by the scale factor. Our next example 2, says using equivalent ratios to find missing dimensions. So company's logo is in the shape of an isosceles triangle with two sides that are each 2.4 inches long and one side that is 1.8 inches long. So first of all, we need to remember an isosceles triangle is a triangle where two of the sides are the same length. Okay, so let's say this is our isosceles triangle. It says two sides are 2.4 inches. So this is 2.4, this is 2.4, and one side is 1.8. Okay. On a billboard, the triangle and the logo has two sides that are each 8.4 inches. So in the billboard, the triangle is 8 inches and 8 inches. And we need to find what is the length of the third side of the triangle on the billboard. So we're trying to find the third side of this triangle. So for this triangle, we're going to set up a proportion now equivalent ratios. Remember, proportions are equivalent. We're going to set up proportions in order to solve this equation. Okay, so what we're going to do is we're going to do this 2.4 over 8, so 2.4 inches over 8 feet, and that's equal to 1.8 inches over X amount of feet. Okay, let's call this X. Okay, now you have to remember, for setting up proportions, we have to do the same sides. So remember, this side length is the same as this side length. And the reason we know that is because this side and this side are the same, and this side and this side is the same. So we're doing 2.4 divided by 8 is equal to the same triangle 1.8 divided by X. Okay, so these are our proportions. Now we're going to solve for our dimensions. Okay, and the way that we solve is we're going to do cross multiplication. We're going to do X times 2.4 and 1.8 times 8. So first we're going to do 2.4x is equal to 8 times 1.8. Okay, so now we have 2 times 2.4x is equal to 8 times 1.8 is 14.4. So I'll rewrite it over here. 2.4x is equal to 14.4 divided by 2.4. And we're going to get x is equal to 6. Now we have to remember, what unit is this? We want feet, so it's going to be 6 feet. Okay, so just to reiterate, we did 2.4 over 8 is equal to 1.8 divided by x, because we need to keep the sides the same. It's really important to make sure that we have the same sides for each one. Okay, then we set up a proportion, and then we did 2.4 times x, and then 1.8 times 8. Set it up. 2.4 times x equals 8 times 1.8. 2.4x equals 14.4 divided by 2.4, and then we got x is equal to 6 feet. Alright, last one. So this one says identify which figures are similar, so which rectangles are similar. Compare similar figures, and we're trying to figure out if they're similar. We have to compare the ratios. Okay, so we have to compare the ratio of rectangle A and rectangle B, and then we're going to compare A to C and then B to C. We're going to keep comparing one by one to see which one is going to be our correct one. So 2 over 3 which is this side divided by this side, and we have to keep them the same. Okay, the same sides have to go on the same sides. So the blue needs to go on top, the red needs to go on bottom. So it's going to be, it's equal to 3 over 4. Okay, because remember, 2 and 3 go together because they're the same side, and 3 and 4 go together. Okay, so now we have to see, are these the same? To see if they're the same, we're going to cross multiply. We're going to do 2 times 4, so 4 times 2, and 3 times 3. And we get 8 is equal to 9. That is not similar because these are not equal. So let's try the next one. Let's try B and C now. Or let's do A and C. A and C. So A is 2 over 3. Excuse me, that is not right. A is going to be 2 over 4 is equal to 3 over 6. So now let's see if these proportions, if these ratios are equal, if it forms a proportion. So 2 times 6 is 12. 4 times 3 is 12. So these check out. So what we know is rectangle A is similar to rectangle C. Okay, this squiggly right here is similar. So we're saying rectangle A is similar to rectangle C. Alright, don't forget to do the exercise for tonight, and then I'll see you guys tomorrow.